In section 3.6, we're going to continue with our use of truth tables. The first thing we're going to look at is conditional statements, but this time what we're going to do is we're going to negate our conditional statement. And there's a pattern. Whenever you negate a conditional statement, remember you're negating everything inside the parentheses. It's going to be equal to or equivalent to, and the pattern is keep and negate. So you keep the first statement the way you see it, you change the arrow to an and, you negate the last statement. So keep and negate. Example 1, we want to verify that these statements are equivalent, which means we're going to construct our truth table with P and Q. So P is true, true, false, false. Q is true, false, true, false. I'm going to look at the negation of if P then Q. First, I need to build up, so I need to do if P then Q. And that would be true, false, true, true. And now I can negate the conditional statement if P then Q. So if P then Q is true, false, true, true, then its negation would be the opposite. False, true, false, false. Now we're going to do P and not Q. I don't have not Q, so I have to figure out not Q first. So if Q is true, false, true, false, not Q is opposite, false, true, false, true. So P and not Q. P is true, not Q is false. So true, false is false in an and. True, true is true. False, false is false. False, true is false. And we've just shown that the statement negation of the conditional statement is equivalent to the and because they match up. False, false, true, true, false, 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 false. In example 2, we want to use this equivalent to write the negation of the following conditional statements. So if I was going to write in part A the negation of the conditional statement, if not P, then Q, that's going to be equivalent to, remember we keep the first statement, so we keep not P, change to and negate the Q. So it's keep and negate. And this would be the negation of our original conditional statement. So let's try another one. We want to negate if Q, then not R. So that would be equivalent to keep and when we negate not R, it's a double negative. So not R is just R. So the negation is the opposite. If you have a not R, it becomes an R. All right, let's try the last one. We want to negate if not R, then not S. So that would be equivalent to keep and negate the negative or the not S becomes an S. Okay, so now we've shown the equivalence with the negation of a conditional statement, and we've practiced using that equivalence. Example 3, we're going to look at something that's in words. So let's say that we wanted to write the negation of the statement, if you do not have wings, then you cannot fly. Well, you could just follow the pattern. First of all, notice that this is the if, then, and then I have my statement, you do not have wings. you cannot fly. So we can keep it in words. Remember, it's keep, the first statement. So you do not have wings, stays. Change the if then to an and. Negate the last. So when I negate you cannot fly, it becomes you can fly. So the negation of this conditional statement, the if then statement, would be you do not have wings and you can fly. So that would be the negation of that conditional statement that I was given. Another thing you can do if you are getting confused by keeping everything in words is you can label your statements. And here I'm just going to let P be the statement, you do not have wings. Typically, we also get rid of the negation, but I'm going to leave it and write P, you do not have wings. And then Q would be the statement, you cannot fly. So the original statement is if P, then Q. So I want to negate if P, then Q. I know it's equivalent to keep and negate. So I know it's equivalent to P and not Q. So now all I have to do is translate that to words. So when I look at P and not Q, P is you do not have wings, and not Q would be you can fly. So it'd be the statement that I originally wrote down. So anytime you get confused if you're in words, you can always label your statements, switch to symbolic form, use whatever equivalents that you're given, and then switch back to words. The next equivalent we want to talk about, and we're going to use this extensively, is De Morgan's laws. So here are De Morgan's laws. There are two. What De Morgan's laws does is it gives us a way to distribute a negation on the outside of parentheses. But remember, this equivalence works both ways. So in the first example, we have the negation of, in parentheses, P and Q. So we can distribute that negation, but when we do that, it's going to be equivalent to change everything in the parentheses. If it's a P, it becomes a not P. If it's an and, it becomes an or. If it's a Q, it becomes a not Q. So you're changing everything. However, you can also work on the right-hand side where there are no parentheses, and you can actually factor out the negative and add parentheses. So whenever you're given an equivalence, you can always go in both directions. Let's look at the other one where we're distributing over an or statement. So we have the negation of P or Q. It's going to be equivalent to change everything. The P becomes a not P, the or becomes an and, the Q becomes a not Q. So we're going to verify one of those equivalences, the first one with the and then the other one follows by creating a similar truth table. So we have P, Q, true, true, false, false, true, false, true, false. And I have to first do P and Q, which would be a true, false, 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 before I can figure out what its negation is. And that would be the negation of P and Q. So if P and Q is true, false, 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 then negate that. It's going to be false, true, true, true. Now I'm going to work on the other side, the not P or not Q. So I don't have a not P listed, so I need to figure out what that is. And I also see that I have to do not Q before I could figure out not P or not Q. So P is true, true, false, false. Not P is false, false, true, true. Q is true, false, true, false. Not Q is false, true, false, true. So the or is false, false is false. False, true is true. True, false is true. True, true is true. So again, we needed the truth table to show that these two statements are equivalent to each other. And they are equivalent because they match up true, false in the column. So we have false for both, true, true, and true. We're going to use this equivalence to write a statement that's equivalent to, it is not true that sharks and dolphins have legs. So this is really interesting. Look at that, it is not true that. That's a negation. And it's negating everything that follows. So it is not true that sharks and dolphins have legs. So you see that there's an and in there. This tells me that this is a and a conjunction. So if you can see that P is sharks have legs and Q is dolphins have legs, then symbolically, this is the negation of, in parentheses, P and Q. So I know that that's going to be equivalent by De Morgan's to change everything. The P becomes a not P, the and becomes an or, the Q becomes a not Q. And then I can just translate that into words. However, I didn't label my simple statement, so it's probably best if I specifically say what P is, because notice in the parentheses we have P and Q would be sharks and dolphins have legs. Those aren't even complete statements. So sharks is not a complete statement. It should be sharks have legs. Oops, if I can write without doing a double E on there. Okay, so Q is going to be dolphins have legs. Now I know what P and Q are, so it's easy for me to translate not P or not Q. I could see that it would be sharks do not have legs or dolphins do not have legs. So the caution is just be careful with the it is not true that. Let's see, sharks do not have legs or dolphins do not have legs. And that's fine. That would be a direct translation of the symbolic form, not P or not Q. If you want to clean this up using grammar rules, that's fine. But it's sufficient the way it is. In example 6, we're going to use De Morgan's again. It says, write a statement that is equivalent to, it is not true that you ate a whole pizza or you lost weight. So again, I see, it is not true that. What follows is in parentheses and it's negated. Okay, so we have an or in here. So this would be a negation, and that would be like a P or Q. So I know that this is going to be equivalent to change everything, not P and not Q. Okay, so remember this is in parentheses. So not P. If P is you ate a whole pizza, and I'm negating it, you did not eat a whole pizza, the or became an and. So and you did not lose weight. So you did not eat a whole pizza. And you did not lose weight. Again, this is correct. If you want to grammatically sort of clean that up a bit, you can, but this is sufficient. All right, example 7. We want to use De Morgan's laws to write the negation of this statement. Okay, so we are writing the negation of all romantic movies are emotional and some are funny. I see the conjunction, and remember I'm trying to negate this statement. So if this were P, all movies are emotional, Q is some movies are funny, then this takes the form of a negation in parentheses P and Q. And I know that that's equivalent to not P or not Q. I'm doing this example because I don't know if you've noticed this. All romantic movies are emotional. That's a quantified statement. So P is all romantic movies are emotional. Q, some are funny is actually referring to romantic movies, so some romantic movies are funny. So I'm supposed to translate that to a not P or not Q. Not P, since it's quantified, that goes back to our quantified statements from the very first section. This is an all are. So its negation would be some are not. So some romantic movies are not emotional. Or, now we're going to negate Q. Q is some are. The negation of some are is no are. Or you could use none. So some romantic movies are not emotional, or no romantic movies are funny. So this is a direct translation. I didn't clean it up, but you can probably clean this up and write it so it sounds a little bit better. So quantified statements are a little bit more challenging. And in our next section, we're finally going to be able to talk about arguments. Our conversation will just be on arguments with statements that are not quantified, because once we have quantified statements, everything gets a little bit tricky. So we'll see a little bit of it, and then we'll look at quantified statements in the last section, 3.8. Let's move on to our last example of this section. Example 8, and it helps if I don't have typos. This should be label the simple statements. Do not include negations. Then write a statement that is equivalent to, if it is not raining, then we don't have to stay indoors and we can go sailing. That's a pretty complex compound statement. So the first thing I'm going to do is look at my directions, which said label our simple statements. So let's label the simple statements. I see an if, then. So I can see that maybe P should be it is, but there's a not in there. And the directions said do not include negations in your simple statements. So instead of having P be it is not raining, P is going to be it is raining. So don't forget to read the directions. Then, and then we have, we don't have to stay indoors and we can go sailing. There was a comma there after if it is not raining. So I know that this is all going to be grouped together after the then. I can also see that this is an and. Now, don't is a negation. For Q, it's not going to be we don't have to stay indoors. It's going to be we have to stay indoors. And then the last statement on the other side of the and, we can go sailing. It's fine. There's no negation there. So that's going to be my R. We can go sailing. So I've labeled my statements. I did not include negations. I'm going to translate this statement to its symbolic form. So if it is not raining, that would be a not P. Then in parentheses, we don't have to stay indoors. It's not Q. And we can go sailing would be R. Oh, this is really tricky. So notice that this is a conditional statement. And I know every conditional statement is equivalent to its contrapositive. So I could use what we had in our previous section, that this conditional statement would be switch everything and negate both sides, which would give me a not in parentheses, not Q and R, arrow, and I'm going to do a double negation on the P. So switch, negate, and it's probably better mathematically if I put parentheses around the not P. I'm going to simplify. I'm going to distribute that negation by using De Morgan's law. So remember, De Morgan's law says that everything changes. So the not Q becomes a Q, the and becomes an or, and the R becomes a not R. And this is still in parentheses. And that double negation in front of the P can just simplify to P. I've labeled my simple statements. I did not include negations when I labeled them. I translated my statement to symbolic form, and now I have a statement that's equivalent to my original statement. I'm going to translate that back to words. So that's if whatever's in parentheses, the Q and not R. So if Q is we have to stay indoors, if we have to stay indoors, or not R is we cannot go sailing if we have to stay indoors, or we cannot go sailing. Then P, it is raining. So this statement is actually equivalent to the original statement. If it is not raining, then we don't have to stay indoors and we can go sailing. Although it's not obvious when you look at it in words, once you change it to symbols, use all the equivalents that we've talked about so far, like contrapositive. I used De Morgan's. I also got rid of that double negative. Then translating back to words is not so bad. All right, and I could, again, clean this up if I wish, make it sound prettier, but that direct translation is just fine. So that's it for this section. Our next section, 3.7, is where we finally get to discuss arguments.